Welcome back to Maths Zone African Motives. We are still on our O-level mathematics, and in this case, we are going to consider the vectors as an introduction. So I'm going to bring you back to your Form 3 mathematics, where you worked with translation vectors and so forth. So from the syllabus that you are having, this is part 6.9, where we have got vectors and matrices. So for now, I'm just going to focus on the vectors, all right? So it is very, very important that we understand what we are working with in this class. That is our vectors. So for vectors, according to the syllabus, you must work out vectors in 2 dimensions, where you consider translation and the notation for the translation and so forth. This is your Form 3. So we are going to consider that part, all right, as separate. Then we have got, these are the representations. I'm going to also indicate that one later on, and the operations, addition, subtraction, also the scalar multiplication. This is under the operations. Then we have got the magnitude of a vector. Then from this part, we need to understand a relationship between of these position vectors, equal vectors, parallel vectors. Those are now applications of our vectors, where we consider this in our Form 4 mathematics. That is where we are now considering paper 2. All right. So paper 1, you're going to see that it is your Form 3 mathematics. So for us to understand each other, we are going to consider this as an introduction, working on the translation and the notation that we are going to use as we are representing our vectors. So these notations can be used in any of the translation vector that you're going to consider. So from our Form 3 mathematics, like I said, we are going to consider what we refer to as a translation vector. A translation vector. So we have got 2 things to consider. The translation. We worked with this one before on our transformation, as we considered the transformation of graphs, right? We had translation. What is it that we are referring to? A movement in a certain direction. And this movement is done without turning. So let me just save this one aside. So a translation separately is a movement. This one, a movement in a certain direction. In a certain direction. In a certain direction without turning. Without turning. So this is the consideration. We are following a certain direction without turning. Let's say I have got A and this is B. I want to move in a certain direction from point A to point B. So we can consider A to be in this way. That's A to B. A vector, a translation, the movement. So as we consider that we can move from A to B straight like that. But remember, from our transformation, as we considered a vector, a translation vector, it was a movement that you consider in X and Y. So the vector part is simply a quantity which has direction as well as size. There must be direction in the x-axis, in the y-axis. So this vector AB that I'm indicating like this from A to B, we can move this way in the X, then Y. So we can move in the X, all right? This is X. The X-axis, remember from our Cartesian plan, this is X-axis. This is our Y-axis. So X-axis is horizontal. So we are moving horizontally this way, all right? Then after, we are going vertically to the point B. So this is the movement here from A to this until we have the point B, until we can see the point B. At that point, you're going to move going downwards. You are representing the translation vector AB. So the movement, as we can see that we can have it in the X and in the Y. X followed by Y. So any movement in the X that we are going to have in the X-axis, as we are considering in the X, we can move to the right or we can move to the left in the X-axis. So to the right, that's a positive. To the left, that's a negative in the X. In the Y-axis, the movement can be vertically up. You can have this one vertically going up or vertically going down. So any part that is represented going up is a positive. Anything going down will be a negative. So meaning to say, let's say we moved from A going this side in the X-axis, maybe 3 units. And in this side of the y-axis, we moved 2 units. So going to the right, that's a positive. So our vector AB from the notation that we had here, AB can be written this way, or you can write it in bold. You have to write it in bold. So which is something that I do not advise to represent. It is best for you to present this way, AB with an arrow, all right? So that's from A to B. As a translation vector, we say it's going to be the movement in X. How many units have you moved in the X-axis? To which direction? So in the X-axis, we're going to the right, which is positive to the right. So this will be positive 3. So we're just going to write a positive 3, just 3. Do not indicate the positive, okay? Then in the y-axis, for us to reach the point B, how many units have you moved? 2 units. In which direction? 2 units going downwards. You're facing down. That's a negative. So meaning to say the y is going to be represented with a negative. So we are simply saying AB, this vector AB, is simply representing a movement of what? 3 units to the right. In the x-axis, that's it's either to the right or left. In the y-axis, upwards or downwards. So in this case, a negative 2 represents what? 2 units downwards and 2 units downwards. Just like that. So this is the concept of a vector, a translation vector in actual sense. So when you are given a sketch and you're asked to represent as a column vector in this way, column vector, that's a translation vector. It's simply a movement that you consider in the X and in the Y. X followed by Y without turning. So that is the concept All right. And these vectors, as you consider your translation vector, it can be taken direct from the origin from our Cartesian plane. It can be taken direct from the origin. A vector can be represented direct from the origin, O to A. Maybe this is O to point B, O to point C, whatever that you give it, direct from the origin. Those vectors are given a special name, which is referred to as the position vector. A position vector, always taken from what? Taken from the origin. From the origin. For an example, vector O, A like this, vector OB, all right, vector OC. These are position vectors from the origin. So you simply indicate, let's say, here, how many units have you moved from this point up to here and how many units going up? So maybe vector OA is given as 2, 3 like this. It simply means 2 units in the x-axis to the right. It's positive. 3 units in the y-axis, meaning to say you're going what? Up. It's a positive, so it's 3 units up. So as you are representing the position vector, you represent it from where? From the origin. All right. And we had these vectors that can be represented as A, B, C, D, and so forth. All right. So such vectors such as A, B, vector C, D, and so forth are now referred to as displacement vectors. All right. So let me just save it here. Displacement or free vectors, all right? Displacement vectors. So that's a displacement vector that you are now indicating. It's no longer taken from the origin. The first part that we had here of the position is here, the origin, from the origin. Here, A, B, we do not have O as the origin. So this is simply a displacement vector. Any other vector, as long it is not taken from what? From the origin. That's a displacement vector. So likewise, we can represent these as column vectors, just like if as column vectors from our translation vector concept. So this is the part that I want us to focus on. On this exercise, we were being asked here to write these vectors in the form xy like this, in that format. That's in this format, a translation vector, a column vector that you're given here. So that's a column vector. So we're asked to represent in that manner xy like this, which is the translation vector concept that we are working with. So we are going to consider these line segments as we are given, all right, A, B, and so on. So remember what I said about the movement in the X and in the Y. That is what we are simply given. How many units? And if you consider what is in the X positive as you are going to the what? As you are going to the right. Negative to the left. Positive as you are going up. Negative as you are going down. So the movement is not supposed to you're not supposed to have a twist in the movement. When you are moving, let's say this is point A and this is point B. So the movement in the X like this straight until we can see the point, until we can see this is where we got our point B. Then from that point, you move straight going up, not from B going this. It's supposed to be continuous from A like this. Then this part where we have got our arrow here, this arrow here, we are going to take the tail from there going to B like that. So take note, the movement has to be continuous, not to say you move from A like this. This is our A and this is our B. We move like this. Then from there, you lift up the pen or the pencil. You now consider from B going down like this. This is wrong. This is not supposed to happen on the movement. All right. So you create an L that you're going to work with. All right. Something like that. But that has to be continuous movement. All right. In the X, then in the Y, in the X, in the Y. That is the concept. So that is how we can simply have the presentation of a vector. First X, then Y. So let's consider from this exercise, from this activity, these vectors that we are given. All right, so we can see that from this figure, this is what we're given. All right, so 0, 2, 4, 6, and so on. So in between is going to be 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, the same here, negative 1, negative 2, negative 3, negative 4, negative 5. All right, here, negative 1, negative 3, negative 5. All right, here, 1, 2. All right, sorry. 1, 2, 3, 4, 5, 6, 7. So let's consider the first vector, A to B. This is our point A, and this is our B. Sorry, guys, that's the diagram. It's just something else. This is it, A to B, and the arrow is facing B. All right, from A to B. So you want to indicate the vector AB. So the movement is always X, then Y. How can we move from A going to B? It is this straight that was, but we need to consider now the movement in X, then in Y. So you can see that in X, we're going to start from starting point. Our starting point is A. This is your starting point, and B is the end point. So starting from A, guys, this is where B is. Definitely, we're going to move this way. In the what? In the X-axis. This is horizontal until we can see our point B here. Then from there, we are going to move up from that point up. The tail is from that point going what? Going up. All right, let me consider this way. All right, going up like this. So how many units from that point A? How many units from point A? In the X-axis, how many units have you moved until we can see the point? How many units have you moved? As you can see, the scale, each box represents 1. So each part it's 1, 1, 1. So we're going to move 1. All right. So it's a movement, guys. This is from A. We move 1. All right. 2, 3, 4, 5, 6 until that point. So we have moved what? 6 units in the X-axis, and that's positive because we're going to the right, positive. Then how many units in the Y-axis? From this point, we are moving, going to B. How many units going up? 1 unit, 1 box, which is 1 unit. As you can see, each box is what? 1 unit. So in the Y-axis, we moved 1 unit. So that's our vector AB. That's the indication of the vector AB. So you indicate an arrow like that on top of what? On top of AB. Just like that. Vector AB. So this is how you take our vectors. It's a movement that you have to consider from a certain point to another one. All right. The same here from C to D. All right. This is the movement here from, this is the vector indicated from C to D. So we are going to consider that vector CD. So like I said, the starting point is going to be C. We end at what? At D. So starting from C, we are supposed to move in the X. Are we going to move this direction or this direction? D is here, guys. Look where D is. So it's D, this direction. This is where D is. We cannot move this direction. We do not have D that side. So according to where point C is, D is on the what? D is on the left side. So we're going to move to the left. Remember, X first. Then to reach this point D, we are going to move what? Going down. That's downwards to the point D. We are moving, going down. So this is the movement that you're considering. So in the X, how many units have you moved? All right, from point C, 1, 2. So we moved 2 units going where? To the left. It's a negative. We are going to the left. So that's a -2. And how many units going down to this point D? How many units from that? 1, 2, 3, 4, 5, 6, 7, 8. So that's a -8 going down. We are going down. Negative. That is the case. So vector CD is going to be -2, -8. Moved 1, 2, 3, 4, 5, 6, 7, 8. So this is a vector taken by movement. We are not considering calculations, no. There's another part where we're going to consider calculation, but this one is by movement. By movement. From one point to another. So I want you to continue with this activity. It's supposed to be NGM book 3. So just consider other vectors, all right? Let me see something that can be difficult maybe for you to consider. This one from point, all right, from H to I, like this one, from this point H, from H to point I, this one. So vector HI is going to be taken as what? Remember, is the movement in the X. So from H, we are going to move straight to I like that. But are we going to move from that point I going up or down? No, there's no movement in the Y-axis, but there's a movement in the X-axis. From H going to I, we moved how many units? 1, 2, 3, 4 units going to I. And that's going to the positive, going to the right. That's +4. How many units from that point I going down or going up? We are not going to move any because we are already at that point I, where the point I is. So there's no movement in the Y-axis. All right? This is a similar, but just opposite to here from this one, vector EF. This is E, and this is where point F is. So if you were to consider vector EF, how many units are you going to move in the X-axis? There's no movement. Because where point E and where point F is, they are vertical, it's on the same line. So we cannot move anyway going to the right or going to the left because F is where E is on the same line. So in the X-axis, there is no movement. But there is a movement in the Y-axis from E going to F. That's a vertical line. So that's vertically up. 1, 2, 3. 3 units going up. So that's a positive. They're going up. 3 units going up. So that's our vector EF. All right. So all these guys going to be determined. I want you to determine all from K to L. All right. From this point, KL. All right. Our K to L, we're going to move in the X. All right. Then in the Y axis, like that. So in the X, how many units? 1, 2, 3, 4. 4 units, a positive. We are going to the right. How many units in the Y axis? 1, 2. 2 units going down. That's a negative. You're going down. In the Y-axis going down, that's a negative. So all these guys, you can determine any vector from point G to H. All right? From G to H. You can determine that. So from G to H, we have to move in the X. So this is our X movement until we can see the point H there. So that's the movement. Then we go up to H. So how many units in the X-axis? 1, 2, 3, 4, 5, 6, 7. And that's a negative because we are going to the left. So this is negative. And going up, gonna move 1, 2, 3. 3 units going up. That's a positive in the Y-axis. So that's our vector G to H. All right. So try any vector, guys, that we are given. All right. In fact, yeah, guys, I think we're almost done. We did all this, all right? See, and we are left with this one. This one, I to J, all right? Let's just finish up this one from I to J, all right? So this is our point I, this one, and that's our J there. The arrow is facing there. So in the X, we're gonna move until here. Then going up to J like that, right? Remember X, then Y. So let's move in the X from I there. That's 1, 2, 3. 3 units going to the left. So that's -3. In the x-axis to the left, that's a negative. And how many units going up? 1, 2, 3, 4, 5, 6, 7. So we move to 7 units going up. So that's it. So as well, you can also represent these vectors. Given this vector, you can be asked to represent it on the Cartesian plane the same way you can see here. So you must be able to do that. So this is just a recap, guys. This is just, I mean, a revision here from our basics. So understand the basics. Understand your basics. So this is the representation of a translation vector by a column vector, as we saw, and by a directed line segment, and using that notation. So you must consider that. And like I said, to represent back on the Cartesian plane, given a certain vector, draw line segments to represent the following vectors. We are given those vectors. So guys, take note, this is not by calculation. No, there's no calculation. So far, there's no calculation. There is a calculation later on where we can have these vectors A, B from another vector, vector OB minus vector OA. Those are calculated. You are given that to say this is vector or this is a point, because these vectors, as we can see, they are being taken from what? From points. As we consider A to B, A is a point, B is a point. So I'm going to have another class with you where we are going to consider having the same vectors that we just had, but by calculation now. By what? Calculation. This was not by calculation. No. We are taking it direct from what? From the diagram, from the understanding that a translation vector is simply a movement that is to be taken in the x, then in the y-axis. So do not confuse between that, a calculation and this part. All right, anyways, let us see what we are given. I want to represent these vectors on this sketch that I'm having here. So let me just try and see if I'm going to win. I'm just going to use this 1, 0, 1, 2, 3, 4. Do we have something like 5? We've got -6. Okay, -6, 2, 4. Okay, you're gonna win -2, 4. Oh, why am I changing the scale? We're not going to win. So let me just use 1 throughout, like in between, like this one. 1, 2, 3, 4, 5, 6. -1, -2, -3. -4, 5, and -6. Okay, -1, -2, -3, -4, and this will be 1, 2, 3, 4, 5, 6. So we have got our x-axis, and here this is our y-axis. All right, so I'm just going to use this one to represent the vectors that we are given here. The first one is vector AB, and is 4, 1. AB, which is given as 4, 1, meaning to say from where point A is to where point B is, we must have 4 units in the what? In the X. And 4 units in the X, and that's positive like this, 4. And 1 unit is positive for the Y, we are going up 1 unit. So A can be any point that is your reference point, but B is from A. So you can indicate point A because you're not given like, this is your point A. No, just draw, indicate. So A is your starting point. Let's say our starting point, our A is here. I want us to just see something, all right? Let's hope we're gonna understand each other. All right. So let's say this is where our point A is. Okay, let's say this is where our point A is here. From the point A, we are going to move 4 units in the x-axis going to the right, 4 units. So from this point A, we're going to move what? 4 units. That's 1, 2, 3, 4 from A. We've moved 1, 2, 3, 4. From this point, we are supposed to move what? How many units going up? 1 unit, so that we can have what? Point B. So we need from this point 1 unit going up. So that's at the end here. That's where our point B is, if we are to consider that. So this is our point B, this one. So the vector AB can be represented now by joining the 2 points A to what? A to B, like this. Joining the 2 points, and you indicate the arrow that you are moving from A to B. So that is it. 1, 2, 3, 4 units. Then 1 unit going up. Just like what we had previously here. But you're the one who is representing that vector. So in this case, you have your own starting point, any part, anyone. You can have your point A here. As long as you're going to move 1, 2, 3, 4 units in the X, then 1 unit in the Y, this will be your point B. You simply join indicating R. So point A can be anywhere. It's your starting point. It can be here, it can be here, anyway. That's the starting point of your vector that you are given there. Anyways, that is what you're going to do. So let me take another one. Let me indicate, okay, let me take this one with a negative, but just try, guys, any part, or let me just indicate all of them. CD -6, this is our X, negative, then Y, it's what? Positive. So it's like this. From point C, you're going to move in the X, negative, that's to the left. Then 2 here is positive. That's you're going what? Up. So that's how it's going to look like, all right? So that's -6, +2. So let's consider, remember C, our starting point is the one that is important. So you simply indicate the point C. Let's say this is where our point C is. Let's say this is where our point C is. So from C to this direction where our D is, horizontally to the left, 6 units to the left. So we're going to move 6 units to the left. So that's 1, 2, 3, 4, 5, 6 units going to the left. Then how many units going up? 2 units going up to the point D now. So 2 units from this point, from here, we are going what? 2 units up. 1, 2. So where we are going to meet here, we're going to end. That's where our point D is. So meaning to say, guys, we have created a vector by doing this. All right. We have what? Created a vector that is simply to join C to what? C to D. By joining that, sorry for that, this one, C to D, we have created or indicated a vector, CD. That's it. Okay, let's see another one. E to F. So according to this one, according to this one, it's X and this is Y here. So X horizontally, 2 units from point E. All right. Then to reach the point Y, you're going to move 5 units going down. All right. That's to point F. So this is what you're going to need. So E is our starting point. So you can just indicate it anyway on your Cartesian plane. Let's say this is where our point E is. From point E, 2 units to the what? To the right, horizontally, 2 units to the right. So that's 1, 2. So this is where we are. So from this point, how many units are we going to move? 5 units going down. So from that point here, 5 units going down. 1, 2, 3, 4, 5. So we're going to end at this point. So that was what you're going to simply need. Point E and what? And point F. So with point E and point F that we are having, you simply need to join. That's your vector. E to what? E to F. Like that. So that's a vector EF that we have represented, and the arrow showing from E to F, just like that. All right, another one, it was G to H. So that's -3 in the X, -2 in the Y. So if this is our point G, it's 3 in the X, that's going to the what? To the left. So meaning to say from G, you're going to the left, -3. Then you're going down from that point 2 units to what? To point H, G to H. So this is what we need. So G is our starting point. You can indicate it anywhere on the graph. So let's say this is where our point G is. Anyway, you can even indicate it here. So from this G, gonna move 3 units to the what? To the left. X first. X first. 3 units. So that's 1, 2, 3. So from here, how many units? 2 units going down. So we're gonna count 2 units going down. So that's 1, 2. So that's it. This is where our point H was going to be. So we simply needed something like that. Then we can simply join the two, G and what? G and H, to have our vector. So that's our vector GH. So as we can see, we can actually represent as many vectors on a single Cartesian plane. We can indicate as many vectors as we can. What we just need is to have a starting point. The starting point, the first letter is your starting point. So from that starting point, is it A to point B? How many units in the X are you going to move? How many units in the Y are you going to move? You can indicate or represent any column vector on your own. So this is what you can have. So like I said, we're going to have another class where we are going to refer to the finding of vectors or determining these vectors that we had from points. If we are given points, then you are being asked to determine a vector from there. So just consider working out following this. All right, I think we're gonna cover it after some other classes. Just consider being part of the channel so that you do not miss any other class that you're going to have, and also to join membership for those who can access membership.